In this video, I'd like to explain how we can figure out whether or not something is a factor of something else. And that sounds very generalized, but it's really, if we compare it to things that we already know how to work with, it's not that hard. So let's start basic. Let's determine whether or not 8 is a factor of, let's say, 40. Okay, and this is leading into more complicated examples. This itself is not a complicated example, but we'll be able to come back to this idea to determine whether or not we know how to do the more complicated examples. So if 8 is a factor of 40, what that means is we can take 40, we can divide it by 8, and we can get something so that we have a remainder of 0. That's our goal. It's a factor if we have a remainder of 0. And we know that this is true. 40 divided by 8 is 5 with a remainder of 0. In other words, we can take 40 and we can write it as 8 times 5. That's what we want to be able to do. So since 8 can be written as 8 times a number equal to 40 with a remainder of 0, 8 is indeed a factor of 40. Now let's change this up a little bit. Let's erase these things and let's do another example. So let's say we want to work with not 8 and 40, but let's ask, is 8 a factor of, let's not say 40, is 8 a factor of 45? Well, when I take 45 and I divide it by 8, do I get a remainder of 0? And we know that we don't. We can see here that 8 is going to go in 5 times. So we'll have 8 times 5 plus 5. We get a remainder of 5. And since the remainder is not 0, we have a remainder of 5, then we say that 8 is not a divisor, or it's not a factor of 45. Let's use these ideas to compare this to polynomials and dividing by binomials. If we look at a polynomial and a binomial, and we want to know whether or not a binomial is a factor of a certain polynomial, then what we'll do, and let's just do an example and we'll actually go about it the exact same way. Let's ask ourselves, is x minus 5 a factor of x squared plus 10x minus 30? To figure out whether or not a binomial or a number, if something is a factor, what we have to do is to take whatever we have. In other words, we're going to take x squared plus 10x minus 30. We're going to divide it by x minus 5, whatever we want to test. We're testing whether or not x minus 5 is a factor, so that's going to be our divisor. And what we want to know is, if you divide these, do we get a remainder of 0? And we're going to get a quotient, but what's the remainder going to be when we divide these? If the remainder is 0, then it's true x minus 5 is a factor of x squared plus 10x minus 30. Now, in those last examples that we did, they were a little easier because they were set up nice, and it was just 40 divided by 8 and 45 divided by 8. When you divide a polynomial by a binomial, we have two options. We could either do long division or we could use synthetic division. And I'm going to choose to use synthetic division. So I see that my c value is the opposite of negative 5. In other words, my c value is 5. And on the inside of my synthetic division problem, I'm going to have the coefficients of my dividend. So the coefficients are 1, 10, and negative 30. If you need, and you've never seen synthetic division before, you can look up a podcast for that, but it will be, especially in these types of examples, it will be a lot easier to use synthetic division. So now if I follow my synthetic division steps, I know I bring down the 1, I multiply 5 times 1 and put that here, so that's going to be 5, and I add down. So 10 plus 5 is 15. And now I multiply 5 times 15. I get 75. And I add down, I'm going to get 45. So, when I divided x squared plus 10x minus 30, and I divided that by x minus 5, I get an answer, a quotient of x plus 15, and I get a remainder of 45. So since our remainder is not 0, then this is not a factor. So up top, is it a factor? The answer is no. And the reason why, when I take x squared plus 10x minus 30 and I divide it by x minus 5, I do not get a remainder of 45. The very last thing I said in that last slide was that the remainder was 45, and that's true. But what we want in order for a particular binomial to be a factor, we want a remainder of 0. This is called the factor theorem. The factor theorem says if a particular binomial or a trinomial, whatever, if it's a factor, if we have a polynomial and it's a factor of a larger polynomial, then if we were to use synthetic division or if we were to use polynomial long division, the remainder is 0. These two ideas are connected. If you divide your larger polynomial by this other factor, whatever you want to test whether or not it's a factor, you should get a remainder of 0. If the remainder is not 0, it is not a factor. So this problem says to use the factor theorem to show that x plus 4 is a factor of this larger polynomial function here. F of x is equal to 5x to the fourth plus 16x to the third minus 15x squared plus 8x plus 16. So let's use synthetic division. I see that my c value is -4, so that will go on the outside. And I know on the inside of my synthetic division problem I put the coefficients of my terms. So remember they have to be in decreasing degree, and I'm not allowed to skip a degree. So I go degree from 4, 3, 2, 1, 0. There is no degree that is skipped, so I can just put these in. 5, 16, -15, 8, and 16. And now I'm going to use my long division, or I'm sorry, synthetic division. So I bring down my first number here, 5, and I multiply it times -4, and I put that here. So -4 times 5 is -20. And I add down. 16 minus 20 is a -4. I multiply that times -4, I get a positive 16, and I add down. -15 plus 16 is a 1. 1 times -4 is -4. Add down, I get a positive 4. 4 times -4 is a -16. I get 0. Since I get a remainder of 0, that means x plus 4 is, you can divide out of this larger polynomial. In other words, we can take our polynomial, which was f of x, right? And instead of writing it all out, we know that f of x is just this large whole polynomial. That means I can write this large polynomial here in terms of my factor, x plus 4, what I was dividing out, times the quotient, whatever I divided it out by. So here I get my coefficients of my quotient. I'm going to put that here. So this is a 5x to the third minus 4x squared plus 1x plus 4. And I have a remainder of 0. I'm not adding some random number over here. Now this is comparable to if I had, let's say, I wanted to show that 4 was a factor of, let's say, 24. What that means is I can write 24 in terms of two numbers that are being multiplied without a remainder. And I know I can write 24 as 4 times 6 with a remainder adding in 0. And that's essentially what I'm doing up here as well. I'm adding my remainder. 4 is a factor of 24 because we can write 24 as 4 times 6. X plus 4 is a factor of my larger function here, this polynomial function, because I can take this polynomial function, and if I divide out x plus 4, I get this, 5x to the third minus 4x squared plus 1x plus 4, and I don't have a remainder. It is evenly divisible by x plus 4. Therefore, it is a factor. This podcast, this video, if you take anything from it, what you should take from it is that if you use synthetic division or long division, if you get a remainder of 0, then whatever your divisor was, in this case it was x plus 4, we got a remainder of 0 that tells us that our divisor is a factor of the dividend. When you divide it out, you got a remainder of 0, it is a factor.